Okay, today we are talking percent of Unit 4.6. This is on page 47 and 48 of your ISNs, and we are going to be filling in the right side of the notebook first on page 48. So if you would follow along, we're going to do some definitions first, and then we are going to do some calculations. So up here in this box up here, we are going to fill in this Build Your Vocabulary box. And so I want you to fill in the boxes as I do them. So number one says, and this is the definition of the percent of change. When an increase or decrease is expressed as a percent, the percent is called the percent of change. So the boxes to fill in here are increase or decrease. Okay? So when an increase or decrease is expressed as a percent, it's called a percent of change. If the new number is greater than the original number, that's called a percent of increase. Makes sense, right? And then if a new number is less than the original, the percent of change is a percent of decrease. It goes down. So we're going to take a look at this example here. It says state whether each percent of change is a percent of increase or a percent of decrease, and then find what it is. So the first step is just take a look at the original number. It's 32. The new number is 40. Well, is 40 greater than 32? Yes. So this automatically is going to be a percent of increase because the new number is greater than the original number. But we have to find what that amount is. So let's take a look. It says find the amount of change. Since the new number is greater than the original, the percent of change is a percent of increase. Okay, 40 minus 32 is 8. This is the difference between those two numbers. Okay, so now we're going to find the percent of change, how much it changed, using the original number 32 as the base. Okay, so the amount of change was 8. It went up by 8. The original amount was 32. And we have to express it as a percent. So this goes back to our percent proportion. And now we're just going to cross multiply. Okay, when we solve proportions, we're going to take 8 times 100, which is 800. That's equal to 32 times R. Now we have a one-step equation. And we have to divide each side by 32 to undo that multiplication. So we get R is equal to 800 divided by 32. If we stick that in our calculator, that's 25. So our percent of increase is 25%. So from 32 to 40, that went up 25%. Okay, so that's what we're doing in today's lesson. We are going to take a look at a couple examples over on page 47. Right? It says state whether each percent of change is a percent of increase or a percent of decrease, and then find what it is. So first we're just going to take a look. The original number is 20. The new number is 18. So we're obviously decreasing. So I'm going to put, this is going to be a percent of decrease. I don't know what it is yet, but I'm going to find out. I'm going to take a look at B, this other one. I start at 12 and I end up at 48, so this is increase. Okay, 48 is more than 12. Okay. So now let's figure out what they are. I'm just going to draw a line here so I can keep my examples separate. All right, so my original number is 20 and my new number is 18. So I need to find the difference between the two and then figure out the percent. All right, well, 20 minus 18 is 2. So that's my difference. So now I set up my proportion like this. I put the difference over the original, and that's equal to some percent over 100. Okay. Now I do my cross products. I take 200, 2 times 100 is equal to 20 times x. I divide both sides by 20, or x is equal to 10. So my percent of decrease is 10%. My original was 20, I went down 2, but I also went down 10%. Over here my original is 12, and I know I have an increase because I went up to 48. So I find the difference between the two numbers. 48 minus 12, that's equal to 36. So that is now the difference between the two numbers. So I put the difference over the original. Okay. That is equal to some number over 100. This is my percent. So let's just mark this is the difference between the original and the new. Now I can do my cross multiplication. 36 times 100 is 3600. 12 times x is 12x. I divide both sides by 12, and x is equal to 300. So this was a 300% of increase going from 12 to 48. Okay, catching on here? All right, we're going to convert this now into a word problem, and we're going to see how it works. It says at one time, at one store, the price of a pair of jeans is $26. At another store, the same pair of jeans has a price that is 22% higher. What is the price of the jeans at the second store? Okay, so what don't I know? I don't know a lot of things right now. I know, let's talk about the original. I'm going to let that be this first store. I'm going to let the new be the second store. Okay, I don't know what the difference is. So I'm just going to let that be 26. I do know the first store is 26. And it's less than the second store because the second store price is 22% higher. So this is going to be increase. So I know that the second store, I'm going to let that be X. That is more than the first store. Okay, so I put the difference between the two over the original, and I do know what my percent of change is. It's 22 over 100. All right, so now I have to cross multiply. So this becomes a distributed property problem because this is 100 times x minus 26, and that's equal to 26 times 22, which is 572. Now I have to solve this equation. So this is 100x minus 2600 is equal to 572. Now I add 2600 to both sides, and I'm left with 100x is equal to 2600 plus 572 equals 3,172. Now I divide both sides by 100, and I get x is equal to 3172. So the second store price of jeans is $31.72. Now the key part to this was assigning your variable. I assigned x to the second store. I knew that the second store was greater than the first store because it said it was 22% higher. So when I find the difference between the two, and this one was $26, I would take x minus 26, and I put it over the original. All right, try your practice problems.